Okay, the first one says write a two-column proof. What we know is that ABCD is a parallelogram. Prove that triangle AEB is congruent to triangle CED. So what I do is I'm going to mark up the picture with what I know from my given. So because I know it's a parallelogram, I know that the two sides are parallel. And I know that the opposite sides are congruent. We learned that from our postulates yesterday or 2 days ago. I also know that my diagonals cut to be congruent sides as well. Trying to think through, I know things about the angles as well. I know that my opposite angles are congruent. And that on the side that they're going to add together to be 180. So all I've done here is marked up everything that I know based on the definition of a parallelogram. Now I'm going to work kind of backwards. I'm going to look at the triangles I'm trying to prove. So here's triangle AEB. And here's triangle CED. When I look at the picture, what I can see is that I've proved that they have 3 sets of congruent sides just from my parallelogram definition, which means that I can use side, side, side to prove that they're congruent. So now that I've marked it up, now's when I go into my 2-column and I have to think about what I did. So the first is just my given. So we know that ABCD is a parallelogram. That was given. Now I'm going to go through all 3 of those sides and list that they're congruent. So I proved that BA is congruent to CD because it's a parallelogram. When I do that, I'm going to say that the reason is definition of parallelogram. That's enough information. I know it's a parallelogram, so I know those 2 sides are congruent. Then I'm going to say that BE is congruent to DE. I know that for the same reason. Finally, I can say that EA is congruent to ED. Sorry, not ED, EC. Gotta remember my diagonals because of the definition of a parallelogram. So now that I have my 3 sides, I can go ahead and say that the 2 triangles are congruent. Because of side, side, side.